So now we're going to discuss applications of linear and rational equations. These are word problems. You want to follow these guidelines when solving these application problems. First, read the problem carefully, determine what the problem is asking for, and assign variables to the unknown quantities. You want to write a little statement along here that'll say something like, let x be equal to whatever it is you're trying to find, the unknown value. You want to draw some type of graphic organizer. Maybe it's a picture or a table, and label the given information and also label the variables in your picture. You want to write an equation that represents the verbal model. This is going to be sometimes a formula from physics or geometry or finance, or it might be some kind of equation that you create that is going to be unique to the problem. Then we'll solve the equation and make sure that it is a reasonable answer by checking it back into the original problem. The first type we're going to be looking at are problems from finance that involve just simple interest. As an example, we've got $5,000 being invested at 4% simple interest for 18 months. We want to find the amount of interest earned. If you're talking about simple interest versus compound interest, which we will be discussing in Chapter 4, simple interest is just computed by taking the principal amount times the interest rate times the time. So in our example below, the interest income earned is equal to the amount invested, that is the $5,000, times the interest rate. 4% is equivalent to, in decimal form, 0.04, times the time. The time in a simple interest formula must be in years. That's what it says above. The time must be in years. So for the 18 months, that's why down here they have a year and a half, 1.5 years. So the interest earned off of investing $5,000 at 4% for a year and a half is $300. That is simple interest. In our example, it says Laura borrowed a total of $22,000 from 2 different banks to start a business. One bank charged the equivalent of 4% simple interest, and the other charged 5.5% interest. If the total interest after 1 year was $910, determine the amount borrowed from each bank. Really what we need to do is figure out how did she split the $22,000 that she earned between the 4% interest-bearing account and the 5.5% interest-bearing account. What the last sentence is saying is that her interest that she had to pay on the 4% account added to the interest that she had to pay off the 5.5% account. Note that I turned those interest rates into decimal form. That interest added up to be $910 that she owed after 1 year. Recall our formula for simple interest is amount invested times the interest rate times the time in years. So we're going to be substituting that in for each of these interest expressions. Okay? It's going to be the principal that she invested at 4% times the interest rate of 4% times the time of 1 year. We have to figure out what is the principal that goes in this first set of parentheses there. Also, for the second loan that she took out so much in principal times the interest rate, 0.055, times the time of 1 year. Again, that's going to add up to $910. So the real question here that we need to be answering is how much did she invest at each rate? What was the principal at 4%? What's the principal at 5.5%? Okay, so we're going to let that be our unknown x, or you could use a p there if you wanted to. But I'm going to say let x be equal to the amount that she borrowed at 4%. What chunk of the $22,000 did she borrow at 4%? That's going to go right in here in the first set of parentheses for amount borrowed, principal, times rate, times time. Now, if she borrowed a total of $22,000 and she borrowed X of it here, then what we know is that the expression, the total, $22,000, less the amount that she borrowed at 4%, is the amount left over for her to borrow at 5.5%. Okay, so the quantity 22,000 minus X is the amount borrowed at 5.5%. That's the principal times the rate times the time. Now you see we have an equation or a model set up here that we can solve that has one equation. There's one equation with only one unknown. For the first term, when we go to simplify, X times 0.04 times 1, that simplifies to be 0.04 times X. Over here on this one, we basically need to just run the 0.055 through to both of those terms. When we take 22,000 times 0.055, on your calculator you have 1,210 minus 0.055 times X is 0.055X. Bring down the equals and the 910. Now it's a matter of solving this equation for X, and that is going to give us how much of the 22,000 did she borrow at 4%. Okay, so combining some like terms on the left-hand side, 0.04X combined with a negative 0.055X is a negative 0.015X. Bring down the plus 1210, the equals, and the 910. Next, to get constants on one side, we will subtract 1,210 from both sides. So what we have remaining on the left-hand side is negative 0.015X. On the right-hand side, 910 minus 1,210 is negative 300. Solving for X, we will divide both sides by negative 0.015X. No, not X, just negative 0.015. Leaving us with X on the left-hand side, which is, again, amount borrowed at 4%. When you take negative 300 divided by negative 0.015, that is a positive 20,000. You want to label your answers to these application problems. The label here is going to be the dollar sign. She borrowed $20,000, and again, go back up to your sentence and see what X was. She borrowed $20,000 at 4% from that first bank. And if X is equal to $20,000, she has 22,000 minus 20,000, or 2,000, that she borrowed at the 5.5%. The problem asked us to find how much she borrowed at each rate. There's your answer. The next thing was to check and make sure that it is reasonable. I say let's take each of these principal amounts for each of the two accounts, sub those back in, and let's see how much interest did she pay at 4%. Remember, interest is the principal amount, $20,000, times the interest rate in decimal form, times the time of 1. When you take 20,000 times 0.04 times 1, that comes out to be $800 is what she had to pay in interest to borrow that $20,000. For the next account, at 5.5%, she borrowed $2,000 at the interest rate of 0.055 for 1 year. When you take 2,000 times 0.055 times 1, that comes out to be $110. Now, when you take the two amounts of $800 and $110, that gives you what the problem told us she had to pay in interest, and so that makes sense. That checks.